So what we're going to talk about today is circularity and the circular economy. And this is starting, I guess, to grow in popularity a little. We're seeing more and more information, but I'll mention it again before toward the end of the presentation. But the actual beginnings of circularity and the thinking around it started back in the 1960s. It may have started before that, but that's as far back as we've been able to trace the documentation. So when people started talking about the need to make our processes circular or less linear, uh, but what we've ended up with is a take, make, and toss economy, where we take raw materials, we make something out of them, and then we throw whatever we didn't use away, and then we throw the product away shortly thereafter. So what we're going to talk about is how we got here and what we're going to do about it. There we go. All right. So our agenda for today, we're going to talk about the why, the what, the how, and the when. Uh, And I want to give a shout out to Deanna. She's on the call today, but Deanna is the craftsperson who put together this PowerPoint presentation. Um, I rough out the slides, and then Deanna turns them into art. Uh, so thank you, Deanna. Some background. Our ancestors, most of them came over on boats. Uh, they uh, got here. They, for the most part, they lived on the ship for a while they cut trees and built homes. Uh, they tore out the things they could when those homes had served their purpose. They would tear out the things that they could reuse, and then they'd set fire to the rest of it, and they'd burn them down. Then they'd go back through the ashes and they'd pick up the nails. Why? Because nails were handcrafted back then and they were hard to come by. And you could burn the wood, get rid of the ash, bury it, or distribute it across the field. Uh, and then you could collect the nails and use those nails again in new construction. Uh, it was efficient, it was effective, and it was productive. They went from log cabins to different construction styles and on up to reasonably good and nice homes, some of which are still available in the Danbury area. Uh, but then, the growth happened and the population grew and the need for more kept growing. And the towns and cities didn't want people burning their homes. So, so they said, no, you can't just burn your home down anymore. Tear it down and take it out and put it on that heap of stuff over there. And they created dumps. Uh, they didn't want people putting their garbage in their backyards in compost because it it didn't smell good. It drew critters, and so uh, they said, no, you can't do that anymore. Put that in the dump as well. Uh, so then the homes would be torn down and the materials would be hauled to the dump, and then they'd burn that material uh, and turn it into ash, but the ash would be in the dump and not in the areas where people live. So about the same time that all of that was happening, uh, this guy named Henry Ford started to build cars, and he could build them better than anyone else. Uh, and his whole idea of mass production and moving the product past the workers and allowing the workers to stay in a place uh, was counter to what they had been doing before. In artisan types of industries, which was pretty much everything that prevailed uh, into the early 1900s, uh, the there would be an assigned area to build a product, and the people would bring material in, and the artisan would use that material and build the product, but it was all done in one location. And the artisan had a complete set of tools to do anything and everything he or she needed to do, mostly he's. Uh, and Ford said, no, let's limit the tools that they have, give them specific tasks, and then move the work past them in an orderly way. And we can make a lot of cars this way, and we can make them cheap. Uh, Other industries saw what he was doing, and they said, "Okay, this is good. Let's do that with our product." And so mass production started. Uh, Once we started mass producing, we didn't need the nails from the old house, uh, and the beams were the only thing that we wanted to save. Some of those old hand-hewn beams were really cool, so we would take those and we would store those, save them, uh, and we continued to grow, and we created suburbia, and the dumps grew, and we were in the midst of take, make, and toss, where we would take the raw material, make it into something, and then toss whatever we didn't need. And when we were finished with it, we tossed the product as well. So that's where we got to. There was this very strong shift from the artisan craft in making automobiles, in making homes. And we started to see factories and growing factories. Now, factories had been around for a while for some industries, but not for wide spread industries. Uh, in New England, they were making a lot of linen and cotton fabrics, wool, those kinds of things, and there were mills doing that. Uh, but then the factories came, and then the office buildings, the strip malls, the drive-throughs, uh, and moved us on to more volume with better quality. We could better define the quality, and we could deliver that quality. Uh, but with that came shorter lifespans on the products as well. Uh, the We were growing the throughput, we were growing the output, uh, but we weren't growing more natural resources. We weren't growing more material. Uh, and what we're beginning to see in some areas is our raw materials are not infinite, and so uh, that's going to take some change. In the midst of all of this, we had World War I, World War II, uh, and the GI Bill. When when the soldiers came home from World War II, many of them had educational benefits. They were able to go to school and learn a trade, get degrees that they wouldn't have been able to get otherwise. And so they took advantage of that, and they got educated. Then they wanted more. They wanted the suburbs. They wanted a nice home. They wanted a nice car, and they had the ability to earn the money to buy and have those things. And so that's sort of where we came from. Uh, and the shift from the artisan to the manufactured happened. It's we still have artisans, to be sure. You can go to craft fairs anywhere, but it's even smaller than it was back when that was the only source. But what we found is that our waste stream has grown uh, as fast or faster than our ability to create products. We have created more and more waste. And those of us who have spent time with lean and with theory of constraints, uh, we, we, we've seen that there are a lot of things that we can do to eliminate waste, to reduce waste, and to make our processes more efficient and more effective. Cities grew, and what did they do? They renovated their downtowns. Looked at some photos of Danbury uh, few, 2 or 3 days ago, uh, just checking to see, and there's been quite a bit of renovation. Uh, you've got some sites where you can see some of the older pictures of the city, and then you see the newer pictures. Uh, there's been a there's been growth and renovation. They created malls away from the city center, uh, spreading out, tearing down, and building up. And then the old was moved to landfill operations. Uh, that's the later word for dumps. We don't call them dumps anymore. We call them landfill operations. Uh, so in this shift, we moved from products that we wanted, needed, and uh, we could acquire, buy, uh, to packaged commodities. Uh, think about your last trip to the store. You went. Most everything that you bought was in a package, a box, a bag, if it were a can, a jar, and it was shrink wrapped to protect uh, the non-tamper or tamper-proof packaging. Uh, that all that sprang from uh, an event back in 1982, 83. Um, there was a man who tried to kill his wife using Tylenol. His wife took Tylenol, and he wanted to get rid of his wife, and so he put cyanide pills in a Tylenol tin. Back then, you had a little tin, and you could pinch the ends, and it would open up, and you'd have like 24 uh, Tylenol in this thing. So he knew that when she went to the store, she was going to be buying Tylenol. So he went with her, and he moved ahead, and he put the tin down where he was pretty sure she was going to pick it up. She didn't, somebody else did. And went home, took the pills, died, and they finally caught this guy. But uh, J&J, Johnson and Johnson, were making the Tylenol at that point uh, in New Jersey, and so they pulled everything off the shelf. They had every store, uh, every place that sold Tylenol. They told them throw it away and we'll replace it. Uh, but they purged the shelves throughout the entire country, and including Canada and including Mexico. Everything. They pulled it all off the shelves and threw it all away. Uh, and then they created uh, systemically. They had to create uh, lot traceability, and they did that. Uh, they were using AMAP software. I was involved in that project for a short period of time. Uh, but we we reconfigured AMAPs to do lot control. But more than that, they had to come up with tamper-proof packaging so that people couldn't open a package and then do something to the goods inside and then put the package back, and you wouldn't notice that it had been changed. So it wasn't only J&J that did that. All kinds of companies got into tamper-proof packaging. And so we ended up with the packaging that we have today. Everything is uh, filled up uh, and wrapped and rewrapped and packaged. Uh, you can, you get boxes in boxes, cans in boxes, and all kinds of different uh, iterations of that. But the packaging industry uh, has gone wild, and it's part of marketing, it's part of advertising, and it's part of making things easier to handle as we work our way through the large grocery stores that we shop in today, or multi-purpose stores like a Walmart supercenter. But the the spreading and tearing down and building up has also led to another different kind of economy. Uh, not too not too many years ago, my wife's grandmother died, and she had a house in Los Angeles, just off a major thoroughfare, and about 2 blocks from a big mall. Uh, and when she died, she had a very large lot. Uh, it was probably close to an acre, and the people who wanted to buy that building, they were lined up. I mean, there were offers coming from all kinds of different people, and uh, my father-in-law was sort of taken aback. He said, I wonder why everyone wants this." And what we learned was they didn't want the house, and they didn't want the garage, and they didn't want the fruit trees. They wanted the land. And then they built a 5-story building on that lot and turned it into condos. And then, so it went from being a 2-bedroom house built uh, between World War I and World War II into a 10 condo uh, building that that was worth millions of dollars. So all of this happens, the spreading, the tearing down, the building up, and it's part of the growth. But what we have to look at is where's the waste and how do we deal with that? We need more housing in single family dwellings. We're seeing right now, I'm not sure how it is in Danbury, but here in El Paso, houses are on the market for sale on average about 18 days. And people are paying above asking price for most of the homes that are sold. So it, there are people out there trying to find places to live. They're tired of living in apartments. They're tired of living in the inner city. They want to be further away. But they're building these homes on very small tracts of land. Uh, we've gone from acres to half acres to quarter acres, and now it's whatever we need for fire clearance so that we don't have the buildings uh, touching one another, but they're very close together. Uh, we tear out, we remodel, and we flip. Uh, Huge amounts of that going on, where you have a house that's distressed. Somebody buys it, they go in, they tear out the insides, they put up new sheetrock, they make it as bland as possible, so that it'll be attractive to the widest variety of potential buyers, and they flip the place, sell it for more and make money on the deal. And I'm not making a judgment here. This is how we're doing things. And you walk up and down the streets, and there are dumpsters, these big industrial dumpsters sitting out there, and they collect all that torn out material, and they very efficiently move it to the landfill where it joins the inner appointments from used automobiles, old computers, and packaging materials. So we are turning our homes as we turn them over. We're tearing all that stuff out, and we're filling up dumps with all of that stuff. Is it still usable? Is there other, are there other ways of doing it not as cheaply as using new at this point? But at some point, the new is going to be more expensive. We need to look at how we can reduce. We've made waste handling more efficient, but not effective. How do we collect the nails to reuse them? How do we define what those nails are, and which ones do we need to keep? Uh, we're starting to hear and see in the electronics industry that there are metals like tantalum and some of the other more obscure uh, metals that are very difficult to come by, but they're excellent at what they're needed for. And so now, how do we get those? We're seeing increasing demands for other chemicals, for batteries, for the electric cars, and for hybrids. Uh, they started out with uh, different size batteries and uh, different materials in them, and it continues to change, and they continue to improve as we experiment and grow. But we're continuing to grow other waste streams that we need to look at and say, now what can we do with that? How can we how can we make better use of that? One example of what I'm talking about here is uh, I worked for a division of Cummins for several years. Cummins makes diesel engines. And when I went to work for them, this was the division that does remanufacturing. We, when you go, if you have a Cummins engine in your Dodge Ram pickup truck or in your mobile RV, uh, you take it to the Cummins dealer, you pull in, and he says, "Oh, you're going to need new fuel injectors." Okay, well, how much is that going to cost? Well, I can put in brand new ones, and it'll cost you this, or I can put in remanufactured, and it'll cost you this, and you get the same warranty. Uh, Whatever the warranty is for those, you buy whichever you want. And what we were doing was, if you, regardless of which you choose, they say, well, I can give you uh, $25 off on the cost of your new injectors if you'll allow me to keep your old injectors. And you say, yeah, okay. And because what are you going to do with an old used injector? So yeah, take the break on the price, and they would take those used injectors and they would send them back, and ultimately they would make their way back to our facility, one of our facilities, and they would remanufacture them. And we did that with starters, with alternators, with fuel pumps, with injectors, with engines, uh, everything. We would take whole entire engines, generator sets, all of those things, bring them back and remanufacture them and send them out. But one of the problems we had was we were using oil-based solvents to do the cleaning, and we would clean all of the parts because you have to completely disassemble and then you have to clean, and the cleaning has to be done in a scrupulous way because you don't want any embedded particles left on the metal. You want the metal as clean as you can make it. So we would we would use these oil-based solvents to do that, and then they would be contaminated with various metals and dirt and all kinds of other stuff that we were taking, that they had picked up in the hundreds of thousands of miles they traveled. And then we had to move this oil-based stuff into uh, large drums, and it was considered hazardous waste. So we take that and ultimately we package it up and we ship it up to Utah or Nevada to a hazardous waste dump site, and we would pay the fees to have that done. So one of the first projects I worked on with them was how do we convert from oil-based solvents to aqueous solvents, water-based solvents. And the difference is with an aqueous-based solvent, you can do the same cleaning, but when you're done, you take that liquid and you set it outside. Uh, as John said, it's hot around here, and we're in the desert. So this is the first place I've ever lived in my life where the relative humidity is a single digit. Uh, I'm used to being in New England where, the relative humidity is, 57%, 70%, something along that line. And here it's 2, 5. Yeah. Uh, so you go out, you run, you come back, and your shirt isn't damp. because it already evaporated. So we used that power to evaporate the water out of this, and that left us with solid waste. Well, the solid waste still had some problems, but you could pack a whole lot more into the drum, and it didn't have to go to the same level of security when uh, you put it in the ground. It had a much lower level, so it it cut the cost of getting rid of the waste, uh, but we still had waste that we had to get rid of. Now, I'm not sure if any of you went to the APICS conference in 2015. I did. Uh, Actually, I think I was on conference committee that year, uh, one of about 7 or 8 that I was conference committee. But Sharon, who was the vice president of APICS at the time, uh, thought that this would be a cool thing to do. And so she gave away these bags, 100% recycled. And down at the bottom, I used to be a plastic bottle. Now, the reason this one looks a little worn and torn and stuff is because this is the actual bag I got in 2015, and it's one of my shopping bags. I use shopping bags almost exclusively. During the pandemic, the stores wouldn't allow me to bring them in, and some stores still have a problem with them. But I take them in, and then I pack my own groceries at checkout. I pack my own bags, and that way they don't have to handle the bags because they were afraid to get contaminated from my bags. But anyway, uh, so this was the beginning of creating awareness and doing it through the apex people that were starting to show up. And if you notice, uh, every time you go through an apex event or go to an apex event where there's going to be swag, um, the swag usually has something in it that is recycled or has something to do with green awareness. So uh, we we started in 2015 with Sharon and the shopping bags, and it's gone on from there. But uh, we're seeing more and more of this. Uh, there are whole clothing lines now, and we're not talking about uh, you know where these things, your your Dickie shirt, your Dickie pants kind of thing for a work uniform. We're talking about high end clothing that's made out of reprocessed plastics. Uh, they're taking old clothing and they're reprocessing it. They're taking it all the way back down to the fibers and redoing the fibers, bringing it all back up, and it's completely remanufactured. Uh, so that's one of the larger waste streams right now is in clothing. Uh, we mass produce clothing all over the world. If you want to know, if you want to know where the lowest labor costs are, look at the labels inside clothing in the clothing stores. Uh, you'll see Sri Lanka, you'll see different countries listed on those labels, and and that's because the labor there is cheap, and they can do the sewing there, piece them together, however, what are cutting, piecing, uh, all of the different operations that they do in the clothing industry. But they make more clothing than people need, and so a lot of this ends up in landfills. Uh, it 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 the, the style changes and people clean out their closets and stuff goes to landfills. Companies are starting to look at that and saying, we can take some of this stuff back and we can reprocess it, turn it into something else. And so that again, another step in the awareness. Uh, the plastic bags that you get at the store. Most stores now have a receptacle, usually just inside the front door or right next to the front door, where you can bring back your used plastic bags, and they'll take those, and that requires a different kind of processing. You can't do it through the recycling process in your town, but you can take them back to the stores. The stores collect them, they send them back, and it goes through another processing thing, but it turns it back into plastic film that becomes uh, plastic bags that they print, and they're getting into the reusing of those bags, which cuts down a huge uh, waste stream. That, and we'll talk more about the plastic waste stream. Uh, so this is the beginning of awareness and starting. You may remember that Al Gore won the a huge award uh, for his movie about climate change. At the time, there was a lot of scoffing, a lot of ridicule. There was a very strong resistance to what he was talking about, and people were saying, "Oh, this is this is all new. It's just fiction. People are making this up." Um, I saw an interview with Al Gore. I think it was over the weekend, and they asked him. They said, "Did you think it was going to be like this?" And he said, "No." He said, "What I was talking about was much less than what we've seen now. It's gotten worse." So interesting side note. But think about this and remember, how many of you remember paper drives where uh, the Boy Scout troop or the Lions or the Rotary would sponsor a paper drive, and you collect all your newspapers and everything. People used to get the newspaper and they'd wrap them up, tie them up in bundles. And then when the paper drive happened, they'd drive them down to the center square, and there'd be a trailer, and they'd fill up the trailer with all of this paper, and they'd recycle and reprocess it. Uh, then uh, when I was a kid, my dad owned a store, but if I wanted money, I had to go earn it. And one of the easiest ways to earn it was to take a walk and walk along the roads and find empty bottles that weren't damaged, that weren't broken. As people would buy a soda and then they'd throw the bottle out the window. They'd buy a beer and they'd throw the bottle out the window. All of those bottles were returnable. They were glass, they were returnable, and you got a deposit. In Connecticut, you're still doing this. You pay a deposit on a lot of the containers, and you can get that money back if you return it. This is all part of cutting down that waste stream and getting the product back into a recycling stream, a reprocessing stream. I started out in manufacturing in New Hampshire, and I was working for a company called IPC, International Package Corporation. We had a major customer in Connecticut, was Torrington Bearings in Torrington, Connecticut. Uh, they were a huge customer of ours, but we made grease and oil seals. The company is still there. It's called Freudenberg NOK. The people from Freudenberg uh, got into an agreement with Dave, and they bought 50% of the company, not 51, 50%. They split it, and they refinanced IPC so that IPC could expand, and it grew from 3 factories to uh, 10 factories. Uh, and uh, they make they make their business molding custom parts out of rubber with steel uh, and silicone parts. Uh, and they we in the molding process there was waste. We take the rubber and we put it in the mold, and there was always excess material, and that excess material would go to the dump. We'd send a truck to the dump, basically every day with the rubber waste. And Dave looked at it and said, "Why can't we use this? Why can't we burn it?" And well, the EPA wouldn't want it. It smelled, so on and so forth. But he said, "Well, there's got to be a way of doing this." And so he started engineers working on it. Today, um, through the process that he started, unfortunately, he didn't live to see it conclude. But all of that waste gets reprocessed into pellets, and then those pellets get blended with the fuel oil, and they put it back into the burners, and they use that to heat uh, the heating oil that they use that circulates through the molds to keep the molds at an even temperature. Uh, they have what they call French presses, which use high temperature oils to heat the platens, and they also have electric molds. And they built their own hydroelectric system. So the Newfound River, coming out of Lake Newfound and running down to the Pemigewasset, they had two uh, hydro generating stations on the river, and that provided them with the electricity for the electric mold. Uh, this Dave took over the company in 1962 when his dad died, and he was a very interesting man. He had lived in the woods. He built a home out of logs that he crafted by hand himself, and then he was thrust into this position as president of a company, and he came at it with a sense of how do we not create waste streams, and how do we make it more habitable for the people who work here. Uh, and we had 1,600 employees at the big plant in Bristol, uh, and made a lot of parts. And we were involved with statistical process controls back in the 1970s. So uh, he was a forward-thinking guy who brought a lot to the game. And so he started this, but it's even today it's bearing fruit, and they've gotten rid of the waste stream, even though they're still manufacturing using the same manufacturing processes. Plastic packaging is one of our largest waste streams. There's about 90 million tons per year generated in plastic packaging. Now, about 50 million tons of that gets recycled, and there's an asterisk. Uh, there's some waffles around that number. About 8 million tons gets burned for energy, where they package it up and then they build it, burn it, and use that the heat from the incineration to uh, heat other things. And then 32 million tons, more or less, go to landfills. Now, of the 50 million tons that gets recycled, uh, that's not necessarily what happens to it. It goes into a recycle process, but a lot of that stuff uh, moves away. Here's the caveat. More than 1 million tons of that plastic waste gets shipped out to Asian countries for reprocessing. Uh, that's 157,000 TEU per year. TEU is the capacity of a 20-foot container. Uh, and China, in the last, you probably heard, China has stopped taking our trash. They said, we don't want any more. We, we're generating enough of our own. We don't need yours. Thank you very much. So it goes to places like Vietnam and India, Bangladesh, and others that are taking it, but it's not being recycled. And much of what they say is being recycled in the US actually isn't being recycled. It's making it out of the recycling stream and into the landfill stream or into other more derelict waste streams. So the stuff just keeps going away, but it's not being reprocessed. So what can we do about that? Well, one of the things we need to look at is why do we have so much? Why do we have uh, a can with a label and then you put six of them, you wrap them in a pasteboard, and you have printing all over the pasteboard. You take that and then you put that in a plastic bag and you leave the 7-Eleven. Uh, why do you need to do that? Why not sell them individually or sell them some other way and reduce the amount of packaging. Uh, why not make the packaging biodegradable? And people go, well, that'll be a lot more expensive. No, we look at what this goes back to purchasing 101, where are you looking at the unit cost? Are you looking at the landed cost? Uh, we are looking at the unit cost in some cases because we're not considering what the waste stream is. And if we can reduce the waste stream, then that reduces other costs. It's like waste in the manufacturing process. You eliminate the waste and the costs go away. Now, the company that brought me down here and moved me to El Paso uh, was Allen Bradley, and they were making carbon composition resistors. And their process and the product had been developed back in the late 1909, 1910 timeframe. Uh, and the machinery had all been built between 1910 and 1912. And they moved all of that machinery down here and they set up a plant in El Paso and a plant in Juarez. And we were making carbon composition resistors exactly the same way that they had been making them back in 1915. Uh, and the process hadn't changed. We took carbon powder, we put it into a cylinder that was made of a very basic kind of plastic. Uh, we pressed it in, and then we took leads and we pressed those in on either end, and we sealed the unit so that the pieces wouldn't come apart. And then we put them into big containers and we bathe them in liquid wax and we cook them for days. And we test them occasionally, and then somebody would say, "Oh, that one looks like it's done," and we pull it out, and then it go through chemical baths to clean them and get rid of all of the wax residue, and that was generating another whole waste stream. And then they would go out and they'd run through classifiers that would say, yes, these are good for the top end, these are good for the middle, these are good for the low end, and these are no good. Put them back in the wax and try it again. And so they were doing that. And we had 1,800 people in the plant in Juarez, 1,400 people in the plant in El Paso. And a new company bought us and they said, what would you do if we gave you a robot? And we all sort of just sat there with our, yeah, what would we do with a robot? So we sat down and we went through it and we started not just thinking about the robot, but redefining and redesigning the product layout, how we manufactured the product. And we we came up with some really good ideas and we started to put that together. It took us about 2 years. We got the robot. We bought an air oven instead of using wax bath, and we hooked the logic of the robot up so that the robot had a test, a pre-test that we ran, and then it went to the robot. The pre-test would give us a predictive analysis on what that product could be turned into, the probability index on it, and then uh, we wired in the demand records from the MRP system so that they could see what was needed and what was not needed. Uh, and with all of that, once we got that up and running, uh, we found out that we didn't need 1,800 people in Juarez, and we didn't need 1,400 people in El Paso. We needed about 240 people, and we only needed about a third of the El Paso facility because we were able to get rid of all the extra machines because we only needed one machine for each size of resistor. And we got rid of all of that, and we were making more product with that small footprint than we'd been making before. Our waste streams had gone to virtually zero, and we were making the product so much cheaper than it had been made before. The company was just raking in the money. Um, so these things aren't supernatural. They're not overly difficult. Uh, they start with an idea. How can what could I do to make a change? How could I make things different? Uh, States now are offering deposits as incentives. Connecticut is doing that, uh, and your recycle rate is higher than that in Texas. PepsiCo and Anheuser-Busch have just announced in the last couple of months they're going to a whole new packaging process that uses recycled plastic, and the tops and the bottles are the same, so you don't have to send them separate directions. They can all go together, and you can return them to the stores for refunds. So it's another step towards circularity. These things are starting to come out. How do we make them work better and faster? Uh, you can refurbish or remand. How many of you have cable? And you have in your house, you have a cable box and maybe a DVR. Uh, and that, when it came to you, it looked brand new, but it was probably remanufactured or refurbished. The cable companies, Dish, Spectrum, all of those, they remanufacture, reprocess all of their equipment. You have something that's defective, it ends up going back to a factory. They tear it apart, they find out what's wrong with it, they fix it, they put it back together, and they mass produce the repair and refurbishment. Uh, Diesel engines, transmissions, fuel pumps, injectors from Cummins and Cat. Cummins and Caterpillar uh, compete on a lot of different stages, and they really compete hard in the remanufacturing processes. Who does the better job of remanufacturing? And there's open competition between the two companies. It's kind of fun when you're inside working in that. Buildings and bridges are being refurbished and remanned. Uh, why? Because we can't change the whole interstate highway system, but we can build it back better, not to cop a phrase. Furniture is being remanufactured now, and taxis are being remanufactured or refurbished so that they don't go away. If you ride in a taxi in New York, that taxi may have been in service for 20, 30 years. Uh, they keep remanufacturing them. The first papers on circularity were written in the early 1960s, and then they were further developed in the 1980s. Uh, and uh, as we got more serious about pollution and resolving the pollution issues, uh, they they started, and we're seeing more and more of it now. I put this map in here because I wanted to tell you about right in the center there is the state of New Hampshire down, and you can see the big blue thing just above where it says Concord. That's Lake Winnipesaukee, and just to the right of that, I'm sorry, to the left of that is a river. It runs under the inn and comes on down. It actually starts up in the Connecticut lakes at the border between New Hampshire and Quebec, and uh, it's the Pemigewasset River. It runs down, and then when it gets to Franklin, it becomes the Merrimack River and goes on down and exits through Massachusetts into the ocean. And that river uh, at one time was beautiful, and then they opened a paper mill in Lincoln, New Hampshire, and it was a great opportunity for the paper mill because they could take all of the waste from the paper mill, the cellulose and the chemicals and everything, and just pump them into the river. And so by the early 60s, it was so toxic that it was taking the paint off the buildings. Uh, on the Pemmy, in the town of New Hampton, between New Hampton and Bristol, uh, there's Ayers Island Dam, and it's a hydroelectric dam run by public service. And the water going through the turbines would release the gases. And so downstream from the dam, you would get the gases that were released from the water going through the turbines, and it would just eat the paint off the houses. People were painting their houses every year, trying to keep them to look nice. And uh, one of one of the people who lived in my hometown in New Hampton is a man by the name of Tom Urey, And Tom was upset because he had a factory uh, in that area, and he made canes and crutches from laminated wood. And he had problems with the glues holding the lamination because of the air contamination. And so he became a state legislator in New Hampshire and went to the legislature and said, we need to clean the river. And everybody went, oh God, really? This is big business. It's not going to happen. Well, Tom worked on it and others joined him. And finally, they got some action and they cleaned the river up. Today, that river is one step below potable water as the water flows through the river. It's purged all of the bad stuff out of the river and it's clean water. And it's used for boating, it's used for swimming, it's used for all of the high entertainment things that we do. But it's clean and it's useful and it brings money to the state and it brings money to the businesses around it. Where else can we look to see things like that that need to be fixed that we have the ability to fix and make them better? We need to reduce, we need to reuse, we need to reman, and we need to develop mass reuse and reprocessing. It's an artisan business right now. The people that run uh, the different businesses that remake product, that's all artisan. How do we do that in big business? How do we do that with major corporations and get the money and get the machinery and make it work so that we take these waste streams and we turn them into good products of something else? We need to find alternatives to petroleum-based products because we're running out of petroleum. At some point, it's going to be very, very expensive and we're not going to have much. And we need to create a new social scheme that allows for sustainability. We need to think about what we're doing to the land because we're not growing any more land. And with global warming, we may be getting rid of some land. Um, don't buy land in Florida. Uh, so, uh, what are we going to do and how are we going to make that better? Thank you for your time. I hope you found it interesting. I hope that I've gotten at least one person interested in thinking through a way to stop a waste stream.